Hey guys, welcome to Tech This is Rohit Sharma, and in this video we are going to analyze our full length quiz 1. Okay, and this full length quiz was based upon the pattern of Vssc. Okay, and the total number of questions was 60 in this, and the total marks contained is 240 marks. One correct question is equal to 4 marks, and one incorrect is equal to 1 mark. And before starting the video, I have to announce one thing. Those who have not joined our Telegram group, that is Isro for ECE, please join it fast, because these quizzes are happening since the last 15 days, and also we have launched our India's first test series for Isro Technical Assistant, and the registration will start from 28th of April. Okay, so let's start the video. First, question number 1. In a DC machine, iron losses occurs in armature, yoke, pole core or pole shoe. Okay, this is a kind of DC machine, and these are the pole cores where these pole shoes are like this. Okay, and this is the armature. Okay, the flux is linked here. Okay, the iron losses occurs only in the armature and the pole shoe. Okay, here is the flux linked. Okay, therefore the iron losses will occur in the pole shoe and the armature only. Therefore 1 and 4 is the correct answer, option A. Next, question number 2. Transformer. What is a transformer? Transformer is a constant frequency device, power device. This both A and B or none of the above. Transformer is a both constant frequency as well as a constant power device. Okay, this is something like a transformer. Okay, this is a primary winding, this is a secondary winding, and this is the core of a transformer. The input side power and the output side power always remains same, and also the frequency, that is 50 Hz, always remains same. Therefore transformer is a constant frequency and constant power device. Okay, now next question. The resolution of a 12-bit analog to digital converter in percentage. Resolution is given by 1 upon 2 to the power n minus 1. Okay, where n is equal to 12 bit, 2 to the power 12 minus 1, which is equal to 0.02441. Okay, you can calculate this. Okay, and this will be the answer, option number B. Now question number 4. Question number 4 is the number of output pins in a microprocessor. Okay, in the answer key, the answer is wrong. I have given the answer there is 40, because 40 is the total number of pins, but the question have asked that the number of output pins. Total number of output pins are 27. Therefore option B is the correct answer here. Now question number 5. The correct sequence of steps in the instruction cycle of a basic computer is. Okay, first of all you will fetch the data, then decode, then read its effective address, and then you will execute the data. Therefore option C is the correct answer here. Question number 7. A memory has a total number of 8 memory chips, each with 12 address lines and 4 data lines. The total size of the system is given by 2 to the power n into m, where n is the number of address lines and the m is the number of data lines. Okay, therefore 2 to the power 12 into 4, which is equal to 2 to the power 12 into 4, which is equal to 2 to the power 2, I can write this, and 2 to the power 10 into 4. Okay, 2 to the power 10 is k, and 4 into 4 is 16k. Therefore 16k bytes is equal to the correct answer. Therefore option D is the answer. Now what is a modulator? A modulator is a device to impress the information onto a radio receiver. Therefore option B is the correct answer here. Now question number 9. What is question number 9 saying? A carrier is amplitude modulated by 4 signals of frequency: 10 kHz, 15 kHz, 20 kHz, and the 25 kHz. What is the bandwidth? Bandwidth of a modulated signal is given by twice of FM, that is the maximum frequency. Here the maximum frequency is 25 kHz. Therefore 2 into 25 is 50 kHz is the correct answer here. Therefore option B is the correct answer. Now question number 10. In a TV transmission, amplitude modulation is for picture and the frequency modulation is for sound is employed. Therefore option A is the correct answer. It is a URSC 2019 question. Okay, this is a previous year question. Question number 10. Yes, in OSI network architecture, the routing is performed by a network layer. That is B is the correct answer here. Question number 12. If two signals modulate the same carrier with different modulation depths, okay, that is M1 is given by 0.3 and M2, that is a different second modulation, is given by 0.9. Okay, now we have to find the resulting modulation, that is total modulation, which is equal to square root of M1 square plus M2 square. Okay, so square root of 0.3 square plus 0.9 square, which is equal to 0.3 square is 3 to the 9, 0.9 plus 0.81. On solving this, you will get around 0.95 as the correct answer here, and the resultant modulation index will be 0.95. So option D is the correct answer. Question number 13. A 4-bit sequence counter has flip-flops having propagation delay of 15 nanosecond each, and the AND gate have a propagation delay of 29 nanosecond. Therefore, total propagation delay will be 70 nanosecond. Okay, 50 plus 20 is 70 nanosecond, and the maximum frequency can be calculated by maximum frequency of clock can be calculated by 1 upon met propagation delay. That is 1 upon 70 nanosecond. Therefore, 1 upon 70 nanosecond, it will be 10 to the power 9. Therefore, 10 to the power 8 upon 7, which will be equal to 10 to the power 2 divided by 7 into 10 to the power 6, that will be megahertz. And on calculating this, you will get 14.3, that is 14.3 megahertz. Therefore, option C is the correct answer here. Question number 4. In question number 4, you have to see which is a D flip-flop, which is a T flip-flop, which is XOR, and which is half adder. Okay. The second will be a D flip-flop here. Okay. Then T flip-flop will be third. XOR gate will be fourth, and half adder will be first. Because in half adder, XOR gate will be there for sum, and AND gate will be there for carry. And here for XOR, you can convert this Boolean function, and you will get A XOR B simply. For D flip-flop, you know that for the same input we get the same output, and for T flip-flop we will have a toggle condition. Therefore, option B is the correct answer here. Question number 15. In this also, you have to calculate this. From here, you will guess X XOR Y. Now put this input here and put this X input here. On calculating this whole function, you will get X XOR Y as the correct answer only. Therefore, option A is the correct answer here. Question number 16. I have already told you the table for this NOR gate. How many NOR gates are used to implement AND gate? Total number of 3 NOR gates are used to implement NAND gate, and if you have to implement NAND gate, this is for NOR gate, and if you have to implement for NAND gate, you will have 2 NAND gates to implement AND gate. Okay. Now question number 17. In a Boolean algebra, this is given. What is the function? Now I am multiplying this A bar plus AC, opening the brackets, A bar B plus BC. Okay. A bar will be 0. AC plus A bar B plus BC. Okay. Now A into A bar, here the redundant terms will be. BC will be the redundant term here. Therefore, answer will be AC plus A bar B. You can find this also by applying this in a K map. Okay, like this. A bar A, B bar C bar, B bar C, BC, BC bar. Okay. Now AC, A, C, C are here in both the terms. Therefore, this and this. Similarly, A bar B, B are both in both the terms, and BC is in BC, and simply BC will be there. Okay. This and this, you will get this only. AC plus A bar B is the correct answer. Therefore, option C. Next question. Amplifier without feedback has a gain of this. Okay. That is A is equal to 1000 and beta is given as 0.009. Okay. Now what is the gain with the negative feedback? We know that negative feedback has the formula as A plus 1 beta, A 1 plus A beta. Okay. Now on calculating the 1000 upon 1 plus 0.009 into 1000, you will get 1000 upon 10. This will be 100 as the answer. Therefore, the gain with the negative feedback will be 100. Option C is the correct answer. Now question number 19. For a transconductance amplifier, input and output resistance are respectively. For a transconductance amplifier, the input resistance will also be infinity and the output resistance will also be infinity. Therefore, option D is the correct answer here. Now, question number 20th. An op-amp has a differential gain, that is AD, which is equal to 10 to the power 3. CMRR is equal to 100, and the output voltage of the op-amp is given as, with inputs of 120 millivolt and 80 microvolt. Sorry, 120 microvolt and 80 microvolt. Okay, these are the output voltage given. Okay, from here you can find the differential voltage and the common mode voltage, that is VC. Common mode voltage can be given as one half of 120 plus 80, which is equal to 100 millivolt, 100 microvolt, sorry, And similarly for differential, 120 minus 80, which is equal to 40 microvolt. This is how you can find. Now for output voltage, we have to find the output voltage. The formula for output voltage will be AD VD plus AC VC. Now you don't have common mode gain, which is AC. Okay, now we are converting this formula in terms of CMRR, that is the common mode rejection ratio. Okay, now see how we can convert this into common mode rejection ratio formula. V0 is equal to AD VD 1 plus 1 upon CMRR Vc upon Vd. On putting all the values in this formula, you will get V0 is equal to 41 millivolt as the answer. Therefore, option B is the correct answer here. Now, next question. In case of amplifiers, which coupling gives the highest gain? Transformer coupling in case of amplifier gives the highest gain. Therefore, option A is the correct answer. Now, question number 22nd. In an NPN transistor is operated at VCE, which is equal to 5 volt, and IC is equal to 100 microampere. Okay. Now, you have to find the input impedance, and the beta is given by 100. Okay. Now we know that IC is equal to beta times of IB. IC is equal to 100 microampere. Beta is given as 100, and IB we have to find from here. Therefore, IB is equal to 100 microampere upon 100, which is equal to 1 microampere. Okay. Now the resistance, that is the input resistance RB, can be given by VT upon IB, and we know that VT at room temperature is 25 millivolt upon IB is given as 1 microampere. On solving this, you will get 25 kilo ohm as the correct answer. Therefore, input resistance is option A. Next question, question number 23. A circuit using the BJT is shown in the figure. Okay. Now here, this is the emitter junction, this is the collector junction, and this is the base junction. Okay. Now from here, I can find our IE, that is the emitter current, which is equal to VC minus VE upon my RE. Okay. Now VCC minus VE upon my RE, that is equal to 10 minus 1.7. 10 minus 1.7 upon RC is 5 kilo ohm, which is equal to 1.66 milliamps. Now you can find IB. IB is equal to VB upon 100 kilo ohm. VB is given by 1 upon 100 kilo ohm, which is equal to 0.01 milliampere. Now we all know that IE is equal to IC plus IB. Okay. Or you can say that IE is equal to 1 plus beta times of IB. Okay. And IE is equal to 1.66 milliampere upon IB. I am taking here on LHS side. IB is 0.01 milliampere, which is equal to 1 plus beta. On calculating this, you will get 166. Okay. Therefore, 166 is equal to beta plus 1, and beta is equal to 166 minus 1, which is equal to 165 as the correct answer here, option C. Now, next question, question number 24th. A 6-volt Zener diode shown in the figure has a 0 Zener resistance and a knee current of 5 milliampere. That is, the knee current of 5 milliampere is flowing here. This is 6 volt. Therefore, now the current flowing through this resistance will be 10 minus 6 upon 5, 50. 10 minus 6 is 4, 4 upon 50. I am calculating this 2 upon 25. Okay. Now you will get around 80 milliampere here. This will be 80 milliampere. 80 milliampere. Now 80 milliampere is flowing here. Then how much current will be flow in this branch? 80 milliampere minus, that is the IR branch, IR current flowing. 80 milliampere minus 5 milliampere, which is equal to 75 milliampere. This is to satisfy KCL, that is Kirchhoff current law. Therefore, the current in the R resistance branch is 75 milliampere. Okay, now we have to find the resistance. Now I can write 75 milliampere, that is the current flowing through this, is equal to V by R, that is 6 upon R. Now R is equal to 6 upon 75 milliampere, that is equal to 75 into 10 to the power minus 3, which is equal to 6000 upon 75. The answer will come out to be, the resistance will be 80 ohm is the correct answer, option B. Next question. Now consider the following statement. Before we read this statement, In this, one thing is missing, that is the intrinsic concentration. The intrinsic concentration depends upon the following factors. Okay, first it depends upon doping. Second, increases exponentially with decrease of band gap of semiconductor. Third, increases non-linearly with increase of temperature. Increases linearly with increase in temperature. Now for intrinsic concentration, we have studied this formula, that is Ni square, which is equal to A naught T cube e to the power minus Eg naught upon Kt. Now Eg naught is the energy gap at 0 degree Kelvin, T is the temperature. Now here you can see the temperature is non-linear. The intrinsic concentration will non-linearly increases with the temperature first, and secondly increases exponentially with decrease of band gap. Okay, decrease of band gap of the semiconductor. Therefore second and third is only correct in this equation. Therefore option C is the correct answer here. Now next question, the whole concentration, that is the P, is given as 2.25 into 10 to the power 15, and the intrinsic concentration, that is Ni, which is equal to 1.5 into 10 to the power 10. Now we know that N is equal to Ni square upon P, because by mass action law we have studied that Np is equal to Ni square. Therefore N is equal to, Ni will be 1.5 into 10 to the power 10 whole square upon 2.25 into 10 to the power 15. Okay, on solving this you will get 2.25 into 10 to the power 20 upon, this will be 2.25 into 10 to the power 15. This will get cancelled with this, and this will get 10 to the power 5. Therefore 10 to the power 5 is the correct answer, option C. Next question, question number 27. Which component opposes voltage change? Okay, you have seen this equation, I is equal to C dV by dt and V is equal to L di by dt. Okay, so please remember the inductor opposes the change in current and the capacitor opposes the change in voltage. Therefore capacitor is the correct answer here, option C. Next question, what happens when a heat is applied to a joint ends of the wire of a thermocouple? Always a small voltage is generated in this. Okay, option C is the correct answer. Question number 29. In a center tap full wave rectifier, 100 volt is the peak voltage between the center tap and one end of the secondary. What is the maximum voltage across the maximum voltage across the reverse bias mode is given by PIV, that is the peak inverse voltage. And remember, the peak inverse voltage for a center tap full wave rectifier is 2 Vm, that is twice of the maximum voltage. And the maximum voltage, that is the peak voltage, is given as 100 volt. Therefore 2 into 100 is equal to 200 volt is the correct answer here. Therefore option A. Now next question, question number 30. Which of the following is the fastest switching device? If they are saying that what is the switching device, which fastest switching device, then fastest switching device is MOSFET. Okay, therefore option C is the correct answer. Question number 31. They have said when the firing angle of a single phase fully controlled rectifier feeding constant DC current into the load is 30 degree. Okay, now this is a question from power electronics. They have said us to find the displacement factor of the rectifier. For rectifier, the displacement factor is given by cos theta. Okay, cos theta or cos alpha, you can say the firing angle, and the firing angle is given as the 30 degree. Therefore cos 30 is equal to root 3 by 2, which is the correct answer here. Root 3 by 2, option D. Next question, question number 32. A transmission line is distortionless, okay, if and only if when R upon L, that is the resistance upon inductance, is equal to G upon C. G upon C. Therefore G is the conductor and C is the capacitance. Now cross multiplying this, we will get RC is equal to LG, GA. Okay, therefore option B is the correct answer here. Question number 33. This is a question from network theory. Okay, now you have to find the value of the current I flowing here. Now 1 ampere current is flowing here, and if 8 volt is across this branch, then 8 volt is also across this branch. This is 8 volt. Now what is the current flowing in this branch? We can find out by 8 minus 2 upon 2, which is equal to 6 upon 2, which is equal to 3 ampere current is flowing through this branch. Now 3 ampere current is flowing through this branch. When 3 ampere current is flowing through this branch and 1 ampere is flowing through this branch, then to obey Ohm's law, to obey the KCL law, that is the Kirchhoff current law, then 2 ampere current will flowing through this branch. Then only 1 plus 2 will be 3 ampere. Therefore 2 ampere is the correct answer. This is a logical based question. You can easily solve by mind. You don't have to calculate anything here. Okay. Now question number 34th. Question number 34th is what is the current through the 2 ohm resistance for the circuit as shown in the below. Now how can we do this question? Easily apply KCL here because 20 volt is across this also. Now I am applying KCL here. This will be minus 6V or minus 6V plus V plus 20 is equal to 0. Okay. Minus 6V plus V will be minus 5V, which is equal to minus 20, and V is equal to minus 20 upon minus 5, which is equal to 4 volt is the voltage. V here 4 volt. Okay. Now you have to find the current. Current flowing through this will be V. I is equal to the voltage across 2 ohm resistance, that is V upon R. R will be 2 ohm and voltage will be 4, that we have already found. Therefore I will be current 2 ampere here. Option D is the correct answer. Question number 35. This question I have already given in our previous quizzes. For a series RC circuit, that is R minus JXC. Okay, we have to remember that the impedance is equal to series RC circuit R minus JXC. The power factor corresponds to the maximum power. For maximum power, the magnitude of resistance will be equal to the magnitude of XC. Therefore, when this is equal, we know that tan inverse XC by R. Okay, we have to calculate here. This will be tan inverse 1. Tan inverse 1 will be 45 degrees. Therefore, the angle in this will be phi. The angle between the voltage and current will be 45 degree. Now we know that the power factor is given by cos phi, and cos 45 is given as 1 by root 2, which is equal to 0.707. Now the main thing is this will be lag or lead. For a case in capacitor, this will always be leading. If it is inductor, this will be lagging. Okay, therefore option D is the correct answer here. Question number 36. I have seen many students have ticked paramagnetic as the correct answer, but in this ferromagnetic is the correct answer because they have asked when the relative permittivity of a material is much greater than 1. For much greater than 1, ferromagnetic is the correct answer, but paramagnetic is slightly greater than 1. Okay. Remember this, it is slightly greater than 1, the relative permeability here. Therefore, option B is the correct answer here. Question number 37. In a simple DC circuit with a constant voltage, where the resistance increases, this is a simply based Ohm's law question. Okay. Everybody know V is equal to IR. Okay. Or also I can write I is equal to V upon R. In a simple DC circuit with a constant voltage, suppose constant voltage, then I am referring V is equal to 1. Therefore, I is inversely proportional to resistance. Now they are saying when resistance increases, automatically the current will decrease. Therefore, answer option A will be the correct answer. Now, question number 38. In a class A amplifier, the output current flows for the full cycle of the input signal. Therefore, option B is the correct answer here. Okay. Question number 39. How many flip-flops are required for mod 16 counter? Obviously 2 to the power n, that is equal to 16, then 2 to the power 4 is equal to 16. Therefore 4 flip-flops are required. Therefore option D is the correct answer. Next, you have to find the BCD equivalent of decimal number 43. In the answer key, I have given the wrong answer. Okay, so answer will be this 0100. For BCD equivalent 4, 3, separate out these. In BCD 4 can be written as 0100 and 3 can be written as 0011. Therefore answer will be 0100 0011. Answer is the correct answer. Option C. Next question. Now this, as shown in the figure, 1 ohm resistance is connected across a source that has a load line V plus I is equal to 100. Okay. Now the current through the resistance, if I am saying the voltage through the resistance will be V equal to 1I, therefore V equal to I here. Okay, now V equal to I am putting this equation in the first equation, that is I plus I is equal to 100. Therefore 2I is equal to 100. I will be equal to 50 ampere. This is the easiest question in the paper. Okay, but many students have left this question because of this circuit. Okay, but easily you can do this question by this. I equal to 50 ampere, that is option B is the correct answer. Question number 42. This is a bit difficult question. Because it is a gate level question. Now how we can do this question, let's see. A battery charger can drive a current of 5 ampere into a 1 ohm resistor. Now this is our first circuit where I have taken VTH and RTH. Okay, Now VTH and RTH are supplying a 1 ohm resistance and the 1 ampere current is flowing through, 5 ampere current is flowing through it. Now the equation for this will be VTH is equal to 5 RTH plus 5. This will be our first equation. Okay. Now for second case, if it is able to charge an ideal 2 volt battery at 7 ampere rate, now the circuit will be VTH RTH. Battery, 2 volt battery is charging here and the current flowing through this is 7 ampere rate, and this is RTH and this is VTH. From here 2 volt, from here you can calculate VTH minus 7 RTH is equal to 2. Okay, this will be a second equation. You can calculate here from by applying KVL here and also by applying KVL here. Now on solving equation 1 and 2, you will get VTH by substitution method. You will get VTH is equal to 12.5 volt and the RTH is equal to 1.5 ohm. Therefore option B is the correct answer here. Simply you have to draw the circuit VTH RTH and the 1 ohm resistance, 5 ampere is current flowing through it, and secondly VTH RTH and the 2 volt battery is connected across it and the 7 ampere current is flowing through the battery. Okay. Now we have developed KVL equations from both the circuit and solved by substitution method. Simply VTH is equal to 12.5 volt and RTH is equal to 1.5 ohm, and always the Thevenin equivalent is connected in series. Therefore option B is the correct answer. Now question number 43. The maximum power will be transferred from a voltage source to a load only when the source impedance is equal to the load impedance. Okay, this is the maximum power transfer theorem. Option B. Next question. For a parallel RLC circuit, R is equal to 40 ohm, L is equal to 2 Henry and C is equal to 0.5 farad. You have to find the bandwidth and the quality factor. Now bandwidth for a parallel resistance is given by R root C upon L. Here R is 40, C is 0.5 upon 2. Now 40, this will be 1 by 4, then 40 upon 2 will be 20. The bandwidth will be 20 radian per second. Now you have to find the quality factor. Now formula for quality factor is equal to resonant frequency upon my bandwidth. Now resonant frequency is equal to 1 upon root LC. 1 upon root L, L is 2 into 0.5, then the resonant frequency will be 1 radian per second. Now the quality factor will be 1 upon 20, which is equal to 0.05. 0.5 is the quality factor here. Now bandwidth is 20 radian per second and the quality factor is 0.05. Therefore option A is the correct answer. Question number 45. Torque to weight ratio of an instrument always indicates the sensitivity. Okay. Question number 46. The difference between the indicated value and the true value, that is the measured value minus true value, will be the absolute error to find. Okay. Now question number 47. How we can find this question? A DC voltmeter has a sensitivity of 1000 ohm per volt. Okay. When it measures half scale in 100 volt range, the current through the voltmeter is, you have to find the current through the voltmeter. Okay. When full scale, we have to find the current through full scale, then 1 upon 1000 ohm per volt will be equal to 1 milliampere here. Now for half scale, we have to simply half this. That will be 0.5 milliampere. That is 1 milliampere upon divided by 2. 5 milliampere. Therefore option D is the correct answer. Question number 48. For low resistance measurement, which bridge is used? For low resistance measurement, Kelvin bridge is used. Simple. Question number 49. What is the type number here? Now G of S, H of S is equal to K S plus 2 S square plus 2S plus 3. Now this term represents the type number. Here S, the power of S is 1. Therefore the type number is 1. Therefore option A is the correct answer. Question number 50. For a second order system, natural frequency of oscillation is 10 radian per second, that is omega naught 10, and the damping ratio omega n, okay, zeta is 0.1. Now 2% for 2% settling time Ts will be equal to 4 upon zeta omega n. 4 upon zeta will be 0.1 and omega n will be 10. This will equal to 4 seconds is the correct answer. Therefore, option D. Next question, question number 51. Now, if a damping ratio is 0.5, always when the damping ratio lies between 0 and 1, then the system is underdamped. Remember this. When it is 1, the system will be critically damped. When greater than 1, then overdamped, and when less than 0, then undamped. Therefore, option A is the correct answer here. Question number 52. Consider the following equation. This 2s to power 4 s cube plus 3 square plus 5s plus 10. We have to simply find the roots that lie in the right half of s plane. Now, we are solving this by Rautherwitz, s square, s1, s to the power 0. Now, 2, 3, 10 and 1, the coefficient of s cube 1 and the coefficient of s is 5. Then 1, 5 is equal to 0. Now, 1 into 3 minus 5 to the 10, simply like this. 10 divided by 5 to the 10 divided by this 1. Okay, you will get minus 7 here. Similarly, now you will consider these two. 1 into 10 is 10, 10 minus 2 into 0, 2, 0, 10 upon 1 is 10, simply. Now, this and this, you will get around 45 by 2 here, 45 by 2 here, and this will be 0, and now this will be 10. Now, which you will see here, two signs are changed, plus 2 minus, and then again minus 2 plus. When there are two sign changes are there, then there will be two poles which lie in the right half of S plane. Therefore, option B is the correct answer. Question number 53. The number of control lines in the 8 to 1 microprocessor, 8 to 1 multiplexer will be 2 cube. That is 3 control lines will lie in this. 3. Question number 54. The rating of an alternator is always expressed in kVA because the losses always depends upon the kVA or MVA rating of an alternator. Therefore, option B is the correct answer. Question number 55. This is the previous year question. Trap flag in 8086 is always used in single stepping mode. Option A. Now, VHDL code is given as, for sum this is A XOR B, and for carry this will be AB. Okay. Now, you have seen in half adder. In half adder we use an XOR gate for sum and AND gate for carry, and carry will be AB and the sum will be A XOR B. Therefore, this VHDL code can be implemented by half adder. Therefore, option A is the correct answer. Okay, now question number 57. In PLC, FRD instruction does the following operation. FRD instruction always converts BCD value into the integer value. Therefore, option D is the correct answer. Question number 58. The process of adding impurities to a pure semiconductor is always known as doping. Okay. Question number 59. The RC coupling is used for voltage amplification. Remember this, option A. Now, last question, question number 60. Which of the following is the most popular IC used in timing circuit? You always read the 555 timer IC circuit. 555 timer IC circuit. Okay, for timing, only 555 is used. Therefore, option D is the correct answer. If you have any doubt related to full length quiz 1, you can ask me in our Telegram group, that is Isro for ECE, and to attempt as many as tests like this, you can please join our test series which we will launch on 28th of April, and the registration will start from 28th April and the test series will start in from 8th of May. Okay, so please join the test series as soon as possible so that you can do around 1800 plus questions that will mostly based upon Isro various centers, that is Vssc, hfsc, etc. Okay, so please join the test series, and also if you like the video, please share it with your friends, and also don't forget to subscribe our channel for further updates. Okay, so that I can also feel motivated to bring more and more videos for you. Okay, all the very best for exams. We will meet in the next video.